Hello friends, in the last class we have observed the definition of complex numbers and algebra of complex number and some problems relating to the complex number is considered. Today we will study the definition of some more concept of complex numbers. Neighborhood of a point, point means complex number. By a neighborhood of a point from the set of complex number, we are taking it as normally Z0 in the complex plane C. We mean set of all points, it is denoted by S, Z such that Z minus Z0 is less than delta, where delta is a small positive quantity. We will denote it by N, suffix it is delta into Z0. See, example is mod Z is less than 1 is an example of open disk or neighborhood of a point. Another definition is interior of a point. What do you mean by interior of a point in the set of complex numbers? A point Z0 belongs to S is called an interior point of S if and only if there exists at least one neighborhood of Z0 which is completely contained in S. As I shown in the figure, which will clearly mark that how you are going to identify interior of a point here. I have taken a set there in the figure and I have taken a point Z0 in the set of complex numbers. By the neighborhood, as I have explained, a small hole there, it represents a point there. If you have taken an interior, then the numerical value or modulus value mod Z minus Z0 is less than the delta, positive quantity. That is what the way you can explain interior of a point. Another definition is open set and closed set. If every point of a set S is an interior point of the set S, then we will say that it is an open set. If all the points of it lies only on the boundary, then it is called a closed set. The boundary points represents the closed set and all the points interior of that set S, it is called an open set. Say I have given in a figure that here it is how that open set is denoted and how that closed set is going to be denoted. So in the third figure, it is half dot mark it indicates and inside there is one full circular manner that I have represented. What it represents, it is neither open and nor closed set. Then what do you mean by connected set? In the set of complex number, we'll say that it is a connected. If every pair of points, say Z1 and Z2 in the set of complex number, yes, I have taken it as. In the set of complex number, we will say when it is a connected set. If every pair of points Z1 and Z2 can be joined by a polygonal line that lies entirely in the set, then we will say that that set is a connected set. See in the figure that I have shown you how that the connectedness is going to be observed in the set of complex numbers. See, Z1 and Z2 is connected by a polygonal path as shown. Observe it. Yes. Next, after that, after this basic definition, we are going to study what do you mean by a function as you have defined in the set of real number. We can also define a function or a mapping or a rule in the set of complex numbers. How to define it? I have taken two sets there. One is set S, which is a subset of a complex plane, and another is set of complex number C. By the meaning of function, normally we are denoting by F, S to C, such that, which means that every element in the set has an unique correspondence in the another set C. Here the set S is called domain set and the set C is called codomain set. A complex function can be represented as pair of real valued functions of real variable in the form as shown in the screen. You have taken f of z, that is equal to f of x by x plus iy. Normally you know that z is equal to x plus iy, which we can write it as u of x comma y plus I into v of x comma y. Both u and v are real numbers and that is equal to u plus iv. For example, if we will take f of z is equal to z square, then z is nothing but x plus iy whole square. Simplifying that, we get x square plus iy whole square plus 2ixy, that is equal to x square. It is nothing but I square y square plus 2ixy. We can further simplify it. It is equal to x square. As we know that I square is minus 1 in the last class, so it becomes I square y square becomes minus y square plus 2i x square y square 2xy. Therefore, which we can write it as x square minus y square plus 2ixy. Here real part is u is x square minus y square and v imaginary part is 2xy. Thus, we can write a complex number in the form of u plus iy. We will study some more idea in the next class. Thank you.